Hi guys, here are the rest of the notes for 5.1 from today. So our first word problem is comparing the cost of taking martial arts classes at two different schools. So we have Penny's Martial Arts School that charges basically a $15 flat rate plus an extra $2 for every class taken. And then Riker's Kung Fu World has a $10 flat fee and then an additional $3 per class taken. And the question is, for how many classes will the cost be the same at both schools, and then what is that cost? So really, solving the system of equations that we're going to get out of this problem isn't the hard part. The hard part is getting the equations in the first place. So what we want to do is figure out what x and y are going to represent. Now, since the cost is something that we're being asked about, and that cost depends on basically the number of classes taken, we are going to make x represent the number of classes taken, and the y is going to represent the cost. So we need to come up with two equations, one for each school. And now that we have the variables kind of picked out like this, the equations won't be so hard to write. So Penny's Martial Arts School charges $15 plus an additional $2 per class taken. So we're going to say for that school that the cost, or y, is equal to, I'm going to write it in slope-intercept form, so the x term first. So it's $2 per class taken, so 2x, plus the $15 membership fee. And then for Riker's school, we're going to say that the cost of that school is $3 per class, or 3x, plus the $10 membership fee. And now all we need to do is graph these equations and find out where they cross. Okay, so I've graphed Penny's school in blue and Riker's school in red. And you can see that they're crossing at this point right here, which is 25 on the y-axis, and all the way down here, it's at 5 on the x-axis. So that means that the cost is going to be $25, that the two schools are the same, and that will be when 5 classes are taken. So again, our coordinates here, 5, 25, represent 5 classes. And a total cost of $25. Now, when I first started talking about this section and explaining what a system of equations is and what a solution to a system is, I talked about the fact that every system of equations has either one solution, no solution, or infinite solutions. So we've looked at a few examples that have one solution, and now we're going to look at those other two instances that I talked about. So when you're graphing your system of equations, there are a couple of situations that you might encounter that are different than what we've looked at so far. And these are the special cases. So one special case would be if your lines don't end up intersecting at all. So if your lines don't intersect, they're never going to have a common point, so there won't be any solution. The lines will never intersect if they're parallel, so that's when that's going to happen. And so for your answer, instead of writing an ordered pair, you're just going to write no solution. The other kind of special case that you would have is if you graphed the two lines and they ended up being the same line. So if the lines are the same, then there are an infinite number of solutions. And you will just write, instead of an ordered pair, infinite solutions. So for instance, on this first example, both of my equations are in standard form, so I'm going to graph using intercepts. So on the first equation, my x-intercept is going to be at 4, and my y-intercept is going to be at -1. And then for my second equation, my x-intercept is going to be at 8, which is out here. And my y-intercept is going to be at -2. Now it would have been a little bit easier to see that those are never going to cross if I had the 8 on the axis actually and the lines were perfectly straight. But you could check the slopes of these lines and they would be the same, showing that they're parallel. So these lines will never cross, they're parallel, and we would then write that there is no solution. And then for this last example in the notes, my first equation is almost in slope-intercept form. My x term is over here. So my y-intercept is 4, my slope is -2. So I'm going to go ahead and graph it that way. And then my second equation is in standard form, and it would be pretty easy to graph with intercepts again. So my x-intercept is at 2, and my y-intercept is at 4. And you can see it perfectly coincides with this blue line that I've already drawn. So these equations here were just different ways to write an equation for the same exact line. So in this case, the lines intersect everywhere, and we would write infinite solutions. And that's the end of the notes, so please check on PowerSchool or the calendar here on my website to see the assignment. Since we had a short class today and we didn't get a chance to go over 5.2, you do not need to do 5.2, just do the 5.1. And have a good weekend. I'll see you next week.